Hello everyone, welcome back to another banger video. Today we're going to be doing risk analysis and portfolio optimization in Python. So yeah, let's hop right into it. So before we delve into this coding aspect, let's understand what we're trying to achieve here. Portfolio optimization is the process of choosing the best portfolio out of the set of all portfolios being considered according to some objective. The objective typically maximizes factors such as an expected return and minimizes costs like financial risk. So first, to build our model, we'll need 4 Python libraries. These include pandas for data manipulation, numpy for numerical computations, matplotlib for plotting, and scipy for scientific computations. If you're on the desktop version, you can go ahead and do pip install all 4 of those, but since I'm in Colab, I won't need to do that. Alright, now let's go ahead and actually import them. Sure, this is good. Right, and then after this, we're gonna have to put some data to represent returns of different stocks in a portfolio or the expected return. For this, for now, we're just gonna put random stuff, random numbers, but in a real world situation, we'd put real return. So let's just put 7, 0.1. Alright, let's run this. Make sure it's good. Alright, did I forget a comma? I don't think so. Oh, I forgot commas here. Alright. Alright, looks good. Next, we're going to define our optimization function. The objective of this function is to find the optimal weights for our portfolio to minimize risk, which we'll measure as the standard deviation of returns. We'll also set a constraint that the sum of the weights must be equal to 1. We use the minimize function from SciPy's optimize module. This function accepts our optimization function, an initial guess for the weights, our returns, and our bounds and constraints. The result object gives us our optimal weights. So we've now constructed a simple portfolio optimization model that minimizes risk. Keep in mind that this is a very simplified example. In a real world scenario, we'd be working with more large, more complex data that might have different constraints or optimization goals and definitely different returns. But the core concepts would stay the same. So that's going to be it for this video. If you guys enjoyed or found it helpful, drop a like down below, drop a comment in the comment section, and we'll catch you in the next one.